This video is about a basic overview of the properties of different special parallelograms. Branching off the traditional parallelogram, there are three subsets of special parallelograms that each have their own properties, two of which are the rhombus and the rectangle. The unique part is the third shape. The square has the properties of both the rectangle and the rhombus, which we will see later on. Let's start with the rhombus. These are some of its properties. In a rhombus, all the sides are congruent and all the diagonals are perpendicular to each other. So let's take a look at these visually. Starting off with the first property, suppose we have rhombus ABCD. Using the feature that all sides are congruent, we can say that segment AB is congruent to segment BC, which is then congruent to segment CD, which is finally congruent to segment DA. All four sides are congruent to each other and equal in length. Going on to the second property, let's say we now introduce diagonals BD and AC. Using the perpendicular diagonal property, we can declare that segment BD is perpendicular to segment AC, and vice versa, which means that segment AD is also perpendicular to segment BD. Now we have our next shape. The rectangle introduces two different properties. These include all angles being congruent and all diagonals being congruent. Imagine we have rectangle ABCD. Since a rectangle's angles are all 90 degrees, they're all congruent to each other. Thus, angle A is congruent to angle B is congruent to angle C, and angle C is congruent to angle D. So all of them are congruent to each other, and their measures are equal. Our second property states that the diagonals of a rectangle are congruent. So we can now introduce diagonals AC and BD. Using the definition of the second quality, we can conclude that diagonal AC is congruent to BD, which can be proved using some manner of triangle congruence, but that is not the aim of this video. Our final special parallelogram is the square. The square is different because it has the properties of both parallelograms we've talked about thus far, which means that all of the angles are congruent, the diagonals are congruent, the diagonals in the square are perpendicular, and all sides are congruent, which takes qualities from both the rhombus and the rectangle. So let's talk about each one individually. Again, let's suppose I have square ABCD. Using the first property, we can conclude that all of the sides in a square are congruent, meaning segment AB is congruent to segment BC, which is congruent to segment CD, and finally, CD is congruent to segment DA. To basically summarize, this is something we already know about a square, and that is all the sides are congruent and their measures are equal in length. The second property states that the diagonals of a square are perpendicular to each other. So with diagonals AC and BD, we can state that segment BD is perpendicular to segment AC, and also segment AC is perpendicular to segment BD. Since the square also has four right angles, they will all be automatically congruent to each other, just like in the rectangle. Therefore, angle A is congruent to angle B, which is again congruent to angle C, which is finally congruent to angle D. Finally, the rectangle's property again shows up with the diagonals being congruent. Therefore, diagonal AC is congruent to diagonal BD. You can see all of the overlaps in the triple Venn diagram, where the square shares the most properties in common, having traits of the rhombus and the rectangle. We can use these properties to again solve problems and find missing angle measures or side lengths.